This is the Edexcel hire paper. It's for Friday the 7th of November from 2014. Question number 1. It's your ingredients questions again. Matthew makes 30 pancakes. How much flour does he use? What he uses 120 grams for 10, so multiply it by 3 because he makes 30, so that is 360 grams. The next one, Tara makes some pancakes. She uses 750 millilitres of milk. Work out how many pancakes she makes. Well, to make 10, she uses 300 millilitres. So to make 20, it would be 600 millilitres. Then you need to add on half of 10, obviously 5. So half of that is 150. So it's 750. The other way you could do it is to multiply by 2.5. And the answer to that one is 25. Question 2 is your scattergraph question. Whenever you see a scattergraph question, just double check it is one. You don't have to plot another point here. Draw your line of best fit, use a ruler and a pencil. Describe the relationship between the length and width of a pine cone. Two things you could write. You could put down it's a positive relationship or positive correlation, or you can put down as one gets bigger, so does the other. Either of those is fine. Another pine cone from a tree has a length of 8.4 centimetres. You must estimate the width of this pine cone. This is where you need your line of best fit. You must have this drawn, and you must go to 8.4, which is here, draw up, hit the line and come across, and the answer I got is around 6.2. The mark scheme says accept answers between 6.1 and 6.4, so as long as you're roughly there, that will be fine. You must draw these lines on your scattergraph. If you don't, you will not get the marks for it. It's as simple as that. Question 3. Substitution. This one. F equals 3g, add 7h. Work out the values of f when g is minus 5 and h is 2. Well, I've written it out here for you. So g is minus 5. 3 lots of minus 5 is minus 15. 7 lots of 2 is 14, so minus 15 or negative 15 add 14 is negative 1. There's your answer, negative 1. Factorise 3x add 6. Factorise means put it into brackets. So what number goes into 3 and 6? Well, it's 3. That's why 3 is on the outside. Are there any letters common? No, there isn't. So it's 3 brackets. Well, how do you get 3x? Well, it's 3 times x. And how do you get 6? Well, it's 3 times 2, and there's positive sign in the middle because there is in the question. Next one, expand and simplify. Okay, this is what you do. 5 times y gives you 5y. 5 times 2 gives you 10, and that's negative. 2 times y is 2y. 2 times 3 is 6, and that one is negative also because it's a negative sign. What I've done done my y's first. That's a positive 5y and that's a positive 2y. So that's why it's 7y. And that's negative 10 and negative 6. Or minus 10 and minus 6. So minus 10 add minus 6 is minus 16. You get 1 mark for 7y, 1 mark for minus 16. These next ones I'll zoom into and just see them. It's simplify them. If you're multiplying, you just add the index numbers. If you're dividing, you take them away. So the answers are m to the power 8 and p to the power 4. Question 4. This is a reflection one. That's the answer there. There's 2 ways of doing this. You can use tracing paper, which I'll show you in a minute, or you can do this. If you head in the direction of the line, that is half a gap there. So it's going to be half a gap there. Let's do this point here. It's 1.5 there. So it would be half and a 1 there. If you do that with all of them, you can plot your points and you'll get it that way. If you prefer using tracing paper, which is absolutely fine, it's a good way of doing it, you can do this. Put your tracing paper over the top, draw around the shape, like that. Now you need to know where to put it back down, so I'm going to put a cross at either end of the line, look, on the grid. So when I flip it over, those crosses are going to have to line up with the corners of the grid. So here we go. Let's line my crosses up. There and there. And there you go. You can see that's where the shape ends up. A lot of people, when I mark this, were putting it down here because they're trying to flip it downwards like this. But if the line of reflection is a diagonal, then you've got to be a little bit more careful with it. The one down the bottom, describe the transformation. It's been translated, or it's been translated, or it's been as a translation of 4 minus 1. You get 1 mark for that, 1 mark for that. You should be able to recognise it's been translated. Another word for it, don't write this in the exam, it's basically someone slided it across, or slid it across like that. So they've gone across 1, 2, 3, 4, which is where your 4 comes from, and down 1. So that's why it's negative 1. If it had been up here, it would have been 4, 1. So the top one is your sort of acrossways, and the bottom one is your up or down. 2 marks for that. Next one, there are some green counters, some yellow and some blue and some red counters in a bag. Work out the probability of which one being taken. Okay, so that's probability of green is 0.16, yellow 0.4 and red 0.24. You've got to work out what blue is. You should know that all these need to add up to 1. So I've added them all up, they add up to 0.8. So that must be 0.2 for it all to add up to 1. Mary puts the counters in a bag, and there's 125. Work out the number of green counters in the bag. Put the counters back into the bag. What you need to do is 125, and you need to multiply that by the probability of it being green, which is 0.16. So 125 times 0.16 is 20. So there are 20 green counters in the bag. Question number 6. This is a currency conversion one. It's quite nasty, but I'll go through it with you. There's 2 ways of doing this. You can give your answer in euros or pounds. Margaret is on holiday in France, and she buys an English newspaper, and the cost of the newspaper is €5. In England, it's £2.50. The exchange rate is £1 equals 1.16 euros. Work out the difference between the cost of the newspaper in France and the cost of the newspaper in England. You should be able to recognise from there it's much more expensive in France, because €5 is clearly much more than £2.50, even looking at the exchange rate. That usually happens because either got to print them abroad, or they've got to ship them abroad. Right, what I've done here, 2 ways, I'll go through each one. I've converted £2.50 into euros. So you do that by multiplying by 1.16, so it's €2.90. So it will cost €2.90 in this country, €5 in France. The difference is €2.10. That will get you the 3 marks for it. Or you can convert it to the €5, which is what it costs in France, into pounds. So you divide by 1.16, that gives you £4.31, and the difference there is in price is £1.81. So you've got to give the €2.10 or the £1.81. Next one, sequences. Write down an expression in terms of n for the nth term of this sequence. It's going up in 4 each time, so that's where you get your 4n from, 1 mark for that. And it's -2 because this is your first term, so 4 times 1 is 4, and what do you have to take away to get to 2? You take away 2. Check it here, 4 2s are 8, take away 2 gives you 6. 4 3s are 12, take away 2 give you 10. So you know you've got that one right if you've done that. Is 86 a term in the sequence? It's got that little star next to it, which means you can't just write yes or no, you must give a reason for your answer. Yes, it is in the sequence. It's the 22nd term, because 4 times 22 is 88, take away 2 gives you 86. And the mark scheme says you can just keep writing the sequence down if you want until you get up to 86 by adding 4 each time. That's also fine as well if you're not confident doing that. Next one, it's draw a frequency polygon. What you need to do, yes, it's an easy one this, but only easy if you know it. Frequency polygon, it basically looks like this, and what you need to do is, it doesn't matter what the scale is, but height, and there's 2 people between 160 and 165. So you need to plot between 160 and 165, which is what I've done there, and then go up 2. The next one is between 165 and 170, and you need to plot between those 2 and go up 5. Do that for all of them, connect them up with a ruler, this one, you must use a ruler, and you'll get your 2 marks. Question number 9. The table gives information about some students' attendance at a school on Friday. So all of this is for Friday. The school has a target of 94% of students being present each day. Did the school meet its target on Friday? There's a few things you can start to do here. I've worked out the total number of students in the school, and I've worked out the total number of students who were present. So if you like, as a fraction, the number of kids who turned up was 1,092 out of a total of 1,210. I'll just say that again. The total of the number of students who are present is 1,092, and that's over a total of 1,210. So that's it there as a fraction. So I've used my calculator, and that's your answer. Convert that to a percentage, which is 90.2%, and you can see that it's below the 94% that they're asking for. When I was marking this, there was another really nice way of doing this, I thought, and that's by doing the 1,210, and you multiply that by 0.94, because that is the percentage, well, that's the percentage thereafter. I've converted it to a decimal there. So 1,210 times 0.94. So they want 1,137. I'll put the 0.4 in, but obviously you round that one. They want that many students to turn up to meet their attendance target. That did not happen because they only got 1,092. So at the bottom, look, big no, they did not meet their attendance target. Question number 10 is trial and error or trial and improvement. I'll leave that there so you can see the workings I've done. You're told it is between 5 and 6, so it's usual to start from 5.5. Sorry, it's x cubed, take 2x equals 125. The trick with these questions, they've got to be set out really, really neatly and make it really clear what you've done. So that it's really evident here. I tried 5.5 first. That's what 5.5 cubed is. That's what 2 lots of 5.5 is. And I've shown I've taken it away. That's the answer. And you can see that answer is too high. I then tried actually quite a lot too high. So I tried a much lower one, 5.2. There's my workings. That was also too high. So I tried 5.1, and that was too low. Looking at that, you can see that 5.1 is closest already. But I've only got 3 marks so far. What you must do is do what I call the sandwich. So do the one in between your one that's too low and too high. So that is 5.15. Do exactly the same thing. There you go. So your answer is 5.1 is the closest. A lot of students were putting in the answer of 122.451 as the answer, because obviously it came from there. But no, it doesn't want that. It wants what x is. And x is the 5.1. There you go. Question number 11. Sophia is organising a conference. People at the conference will sit at circular tables, and they've handily drawn a circular table in case you don't know what one looks like. It's got a diameter of 140, and each person needs 60 centimetres around the circumference. So that means when you sit down, you want a good just over half a metre to spread your arms out and eat your food. There are 12 of these tables in the conference room, and 90 people are turning up. Will there be enough room? Most people did this bit correctly. They did circumference is pi times the diameter, so it's pi times 140, which is that. So there's that much room around the outside of the table. If each person needs 60 centimetres, I divided it by 60, so you can get 7.3 people around each table. So obviously that's 7, because you can't actually split someone into thirds. You can, but it's not a lot of fun at a conference. So what you do then, you've got 7 people around each table, you've got 12 tables, so 7 times 12 is 84, so no, there's not enough room, there is only 84 people. Just a quick word of warning on this, what some people did, and I can see why, they got up to this bit, and they did that alright, so they got 439, so they got a couple of marks for that. They then multiplied that number by 12, because there's 12 tables, so they imagine that in terms of total circumference, you've got this figure times 12. The only trouble with doing that is, if you see here, we've got this 30 centimetres left over, but you can't take that 30 centimetres from one table and another 30 centimetres from another table and say, oh, I can squeeze someone else in, because in reality, in real life, you've got to have that space at that table. You can't add all your leftover spaces up, if that makes any sense. Next one. Question 12. Linear graph. This is a nasty one, this, because they didn't give you a nice grid, or they didn't even draw you the thing underneath, but you know, we'll live on, we'll get over it. On the grid, draw the graph of y equals 2x, take 3. Right, this is the bit. For the values of x from -2 to 3. So the first thing you do is write down x and y, and it says here x is from -2 to 3. So -2, -1, 0, 1, 2, 3. That's what you've got to set yourself up with first. Now it's 2x, take away 3. So it's 2 lots of 3, which is 6, take away 3 gives you 3. I always start from this side, by the way, because it's easy to work these out with the positive numbers than the negative numbers. Next one, 2 3s are 6, I'll tell a lie, 2 2s are 4, take away 3 gives you the 1, 2 times 1 is 2, take away the 3 gives you the minus 1, 2 lots of 0 is obviously 0, take away 3 gives you minus 3. You should be able to spot by now, if you haven't already, that it's going down in 2s, so I just kept on going down in 2s. If you wanted to work this out, you can, because 2 lots of minus 2 is minus 4, minus 4 take away 3 is minus 7. Because you've got to draw your own grid, you should know that this is your x-axis going along this way, and that's your y-axis going up and down. Now look, there's a lot of grid space there. You don't have to use it all. I certainly haven't, as you can tell. I drew my x-axis, so it went from minus 2 to 3, because it goes from minus 2 to 3. I drew my y-axis because it goes from 3 to minus 7, so I've gone from 3 to minus 7, and that's all you need to do. And then plot your points, obviously, draw them up with a line. If the line isn't straight and you've got a point over here somewhere, then something's gone wrong, go back and check it. I've labelled it just because I'm showing off. This is one of those questions you know if you've got full marks on it, because it will be a nice straight line. So if you've made one little error, you should be able to spot it yourself. So there's 4 relatively easy marks there, as long as you're confident with that. Question 13, the diagram shows a swimming pool. I'll zoom in so you can see that pool. It's in the shape of a prism. Prism's just a 3D shape. It's empty, all right, and it's going to be filled with water at a constant rate of 50 litres per minute. We'll deal with that in a minute. Without even reading it, you're going to have to work out the volume of this. That's, you know, because I can't figure what else they're going to ask. So what I've done, calculate the volume. The way I calculate the volume is I work out the area of the cross-section. And what I mean by the area of the cross-section, I'm going to just shade a bit off here. I know it's still tracing, but we can see through it. I'm going to work out the area of this bit you can see there. So what I've done is I've drawn in my head a little imaginary line that goes along there. So I'm going to work out, first of all, the area of this bit, which is 15, I'll write it on actually, 1 times 15, and that is 15 metres squared. Then I'm going to work out the area of this bit underneath. I've actually already done this for you down here, I don't know why I'm bothered doing it again. But, now, you need to work out this length along here. Well, if the whole lot is 15, and that is 6, that means that must be 15, take away 6, is 9. So you can see I've labelled it there, 9. If the whole thing is 2 metres deep, and that's 1 metre deep, on this bit must be 1 metre, which I've not labelled it on, but it's just that bit there. So it's a triangle, so the area of a triangle is base times the height divided by 2. So I've done 9 times 1 divided by 2, which gives me 4.5 metres squared. So I've added those up. 15 out of 4.5 is 19.5 metres squared. That's the area of the cross-section, and I'm going to shade that cross-section in. So I've worked out the area of this bit here. There we go. So to find volume, you multiply it by how far it goes back, so that's 10 metres. Here's my workings for it. So times it by 10 metres, that gives me a volume of 195 metres cubed. You will need to be able to do that skill. The next bit is not too difficult either, but you should be able to do that bit. Now it says here, 1 metre cubed is 1,000 litres. I'll zoom in so you can see it. There you go. So we've got 195 metres cubed, so you need to multiply that by 1,000 to get how many litres goes in the pool. And that is what I've done there. It's 195,000 litres. We're told that it fills up at a rate of 50 litres per minute, which is 3,000 litres per hour. I've done that because I've done 50 times how many minutes in an hour? 60. So it's 3,000 litres per hour. So in total, I need 195,000, and it's filling up by 3,000 per hour. So divide those two, and you get 65 hours is your answer. It does say up here also give your answer in hours. This is 5 marks for this whole question. If you can't do this end bit because you're not used to it, that's fine. You can get, I suggest, good 2 or 3 marks by just calculating the volume of that pool, or some marks for just calculating the cross section of the area. But please tell the examiner what you're doing. Look, so I'm calculating the volume, So here's the area of the cross section, so it's really easy to follow your workings. The next question over here is write down the letter of the graph that best shows how the depth of the water in the pool changes as the pool is filled. Right, well, if you imagine this swimming pool, when they start filling it, I'll zoom in a little bit, there you go, it's going to start filling up quite, in terms of depth, it's going to start filling up quite quickly first, because the first little bit, it's not got a lot to fill down here, because it's got this pointy sort of bit down the bottom. So it's going to fill up quite quickly at first, then when it gets to here, it's going to fill up at a much slower rate, because obviously it's got more volume to fill. So looking at these ones, which one fills up quickly first, and then tails off to be a bit slower? It could be C or D, I suppose, but C is much more obvious because it fills up at a nice constant rate there, quite a quick rate there, then it slows down there. D, that's too much of a curve on D, because if you look at it, it's not a curve going up here, it's nice straight edges, so the answer to that is C. Question 14. This comes up every year. Peter has £2,000 to invest in a savings account for 2 years. He finds information about 2 savings account, and there's information. This is a starred question, it's a functional question. You must put down loads and loads of workings for it. So, bonus saver, compound interest. Compound interest means that whatever you earn in the first year is you get interest on in the following year. So let's have a look. So £20,000, let's increase it by 4% for the first year. So I've done that, and you increase by 4% by multiplying by 1.04, gives you that. And for the second year, it's 1.5%, so I've done my £20,800 by 1.015, that's how to increase by 1.5%. A lot of people were writing 1.15 there. That is wrong, because that's increasing by 15%. So be really careful, please. And that's my final answer there, 21,112. You've got yourself 2 marks just for doing that. The fixed rate one is over here. This is just 2.5% each year. So it's £20,000 times 1.025, because that's the multiplier for 2.5%. And because it's for 2 years, I've put a squared thing there. I can do that with this one on the fixed rate and not this one, because here the interest rate stays the same of 2.5%. Here it changes, so I can't. Something in case so there's my total. You can clearly see the bonus saver one is better value. So look, write that at the bottom, clearly show how much they get, and you'll get the 4 marks really easily. Something I think people might have struggled with here is knowing how to convert that to the decimal, the multiplier. Well, the 4% people did really well because they knew that was 0.04. But some people have trouble. Imagine that's 1%, that would be 0.01, and you've got to put another 5 there, look. This one, 2%, 0.02, fair enough. So 0.025. And that's how you do that. Next one, question 15. Cinema sells adult tickets and child tickets. Right, this is simultaneous equations. But you've got to set yourself up with one. So what I've done is this, and I'll talk you through it. The cost of 3 adult tickets and 1 child ticket is £30. So 3 adult and 1 child is 30. The cost of 1 adult and 3 children is 22. 1 adult, 3 children is 22. And what I've got in the box there, that's my simultaneous equation. That's what I've got to try and solve. You need to recognise it's a simultaneous equation question. Right, here's how I solved it. You've got to get your A's or C's the same. I've decided to multiply all of the top by 3 because I'm going to get my C's the same. So 3 lots of 3A is 9A, 3 lots of C is 3C, and 3 lots of 30 is 90. That's called multiplying through by 3, because I multiplied everything by 3. And this line here, I keep the same. I've got a positive 3C and a positive 3C. How do I get rid of them? Do I add up or take away? Well, I subtract, so that's what I've done. I've shown I'm subtracting. 9A take A is 8A. That take that goes to nothing. That take that is 68. I want to get A on its own, so it's being multiplied by 8. So how do you undo a multiply by 8? You divide by 8, obviously both sides. So adult ticket is 8.5. Obviously that's £8.50, but I'll go back, I'll sort that out at the end. Next bit, what you do is if you know A is 8.5, and the posh way of saying this is you substitute it back into one of your original equations. It doesn't matter which one you use. I've used the bottom one, A add 3c is 22 down here, just because I couldn't be bothered to multiply 3 times 8.5, but you can do whichever one you want. So there you go, A add 3c is 22. Well, we know A now is 8.5, so 8.5 adds something, that'll be blank if I'm setting it up, equals 22. So you need to work out what's in this box, and you just do 22 take away 8.5 gives you 13.5. So 3 child's tickets is £13.50. So to find each one you divide it by 3, which is what I've done, and it's £4.50. Okay, so question 16. The diagram represents a metal frame. It could be a frame, I'm not sure what for, could be used hold up a roof of a house or a pub sign. Although, to be fair, it's probably a bit big for a pub sign, but you know, let's not worry about that. It says it's made up of lengths A, B, B, C, and so on. So that's all there. Right, the question says work out the total lengths of all of the bars. So the total length of all the metal used. I think it's really nasty, but we'll get some marks for it anyway. Right, AC, that's, when I say easy to work out, I don't mean that in a horrible way if you didn't do it, but you've got to use Pythagoras for it. So the length of AC is A squared at B squared is C squared. So that's called that one A, that one B, and obviously that whole length there will be C, because there's your right angle for it. So we're going to find out this length here. Here are my workings for it. A squared at B squared is C squared. It's all there. Work it through, square root at the end, 5.83. There's your total answer. Right, the next bit is to work out this one here, and I thought this was really difficult, and even the mark scheme gave a really convoluted way of doing it, so I'm going to show you my way of doing it. What I've done is I've worked out I can find out the area of the triangle, and the area of a triangle is base times height divided by 2. So if you like, that's the base there, pretend this triangle is upside down, that's the base, that's the height, and divide it by 2. So 5 times 3 divided by 2 is 7.5 meters. Then what I've done is I've just turned the triangle around slightly, and now I'm using this as the base here, 5.83, because the height is what we're trying to find out is this one here. Now we know the area because we just worked out at 7.5 meters. So I hope I've explained that well enough. So that's what I've done here. Look, I'm using base times height divided by 2. The base I'm saying is 5.83. The height, I don't know it because I'm trying to find it out. You need to divide it by 2 because that's what you do when you find out the area of a triangle. But I know the area now at 7.5. So I've set that up as an equation. So it's 5.83 times h divided by 2 equal to that. So you need to get rid of that 2. So how do you want to do a divide by 2? You multiply by 2. There you go. So 5.83, zoom in a little bit. 5.83 times h equals 15. I want to get h on its own, so how do you want to do a times by 5.83? You divide by 5.83. So it is h equals 15 divided by 5.83, which is 2.57 meters. So what you do at the very end, look, is you add up all the lengths of the bar. So it's 5 meters, add 3 meters, add 5.83, add 2.75, and it gives you 16.4. It wants the answer to 3 significant figures, which is what I've done. Okay, question 17. This is a circular theorem question. Now we're getting really into the A grade stuff on the paper. A, B, C, D are points on the circumference of a circle. AC is the diameter, but you should be able to recognise that because it goes through the centre there. Anyway, work out the size of the angle DAC. So that is DAC. So I've labelled it X there. Once you get the hang of these, they're quite easy. The trick is to make sure you give absolutely every single reason you can. So, and to do that, you need to know what your circle theorems are. So, I'm going to talk it through one step at a time and tell you what I've done. I've worked out the angle ABC first here. It is a right angle. And I know it's a right angle because the angle at the circumference of a semicircle, and if you imagine that half wasn't there, you've got a semicircle. Hang on, the bit I used earlier, but never mind. There you go, there's your semicircle. So if that point is anywhere along here, as long as it's connected to by this one and this one, it's going to be a right angle. So because the angle at the circumference of a semicircle subtended by the diameter, that's the diameter, is a right angle. So I've got that one in, I know it. Angle ACB, ACB. So I'm going to work out this one now. I think that was quite a nice one actually. There's 180 degrees in a triangle. So it is 180, take away 90, take away 25, gives you 65. But look, I've even shown my workings for that, and I've said there's 180 degrees in a triangle. The next one I'm going to do is angle ADB, which is there. And this is something one of the circle theorems you've got to know. I'll read it out, then we'll have a look at it. That's 65 because angles subtended at the circumference at the same points are equal. And what that means is, if you look here, this line here, you've got two triangles coming off it. You've got a triangle coming off it here, and a triangle coming off it here. Even if that point D was there, and it met with this point here and here, that angle would still be 65 degrees. If that point there was up here, it would still be 65 degrees, because it won't change, because it's fixed here at these 2 points. These are the points here it's hinging off, if you like. So wherever you move it, it's going to stay the same. Once you've done that angle, well, I'll quickly, there you go, if you want to, tell you what, if you want to quickly pause it and read through everything I've done. Take times 2 off. And what I'm going to do is quickly zoom out so you can see the whole thing. So it's probably a bit small, but there you go. Right, let's quickly finish it off. Angle AED is the next one I've done. So let's have a look, where is AED? AED, so that's this one here. You can probably look at that and think, well hang on, if that's 100, that's got to be 80, because there's 180 degrees on a straight line. And now to finish it off, it's easy, because you've got a triangle. So that's 180, take away 65, take away 80, because there's 180 degrees in a triangle. And they're my last two reasons there. So that means the answer must be 35 degrees. You need to get all of these reasons down, because it's 4 marks. If you don't, you'll be losing marks for it. So good luck with that one. Question 18, it's about working out the mean of group data. You've got some information here about adults watching television. It says that 8 adults watched TV for between 0 and 10 hours in a week. 15 adults watched it for between 10 and 15 hours in a week, and so on. To find the mean average, what you do is add everything up and you divide by the number of people you've got. Well, the number of people you've got is 50, because that's there. But you need to know the total number of hours they spent watching television. Now, the trouble is, and this is the reason why it says work out an estimate, is you don't know how long these 8 people watched it for. They could all have watched it for 1 hour, they could have all have watched it for 9 hours. We just don't know. So we've got to estimate that they would have all watched it for, pick the middle point, 5 hours. So that's why I picked the midpoint. The midpoint of this one will be 12.5, that's why I picked 12.5, and so on. So you've got 8 adults who watched, we've estimated, 5 hours of television a week. So you multiply that gives you a total of 40 hours of television. Again, you do the same for the next one and the next one. Then we add them all up, like you would do for any mean average. So once you've added them up, you divide by the number of people you've got, which is 50, which I've done there, and it comes to 18.2 hours. The next part of the question is a histogram question. A histogram it's a bit like a bar chart, but they make it a little bit more complicated because it is an A-grade topic. You need to know this, and you just need to remember it's not written down. The frequency density, and the frequency density is what goes up this axis here. It's what goes up the y-axis, and you need to be able to work this out. The frequency density is frequency divided by the class width. And that's not very difficult to work out. Let's go up here and I'll show you what I've done. There's your frequency. So the frequency is 8. The class width, well, it goes from 0 to 10. So how wide is that class? It's 10 people wide. So we do 8, that's the frequency, divided by 10. Up here, look. 8 divided by 10 is 0.8. On this one, the frequency is 15, divided by the class width. The class width here is 5. So it's 15 divided by 5, and so on. I'll zoom in on that so you can see exactly what I've done. That's how I've worked out my frequency densities. Once you know these numbers here, you can go down and draw your scale on your y-axis. You go up to 3. That's as high as you need to go. So let's have a quick look down here. So there you go. I've just gone 1, 2, 3. Nice and simple. So for the first one, let's have a quick look up here. It goes from 0 to 10 and it goes up to 0.8. So let's have a look what I've done. 0 to 10, look, and it goes up to 0.8. And I've just shaded it in to make it a bit clearer on the visualizer. The next one, the class width is 10 to 15, and it goes up to 3 on the frequency density. Look, goes up to 3. So down here, it is 10 to 15, and it goes up to 3. And I've done this for all of them. If you want to maybe make a note of what I've done there, the frequency densities and the length of times, then you can compare that to what I've done down here. But that will get you full marks on a histogram question. Just stress it again, you need to know this formula. Frequency density equals frequency divided by the class width. Next question, question 19. Louise makes a spinner. This is probability trees, isn't it? When I look at these questions, I'll be honest, you don't even need to read what it's about. You just need to look at this, and you get 2 marks for filling these bits and pieces in. It's either green or red. So if it's green, it's 0.7. If it's red, it's 0.3. These two have to add up to 1. Because it's certain she'll spin a green or spin a red. Second spin, because the spin is still the same, it hasn't changed as far as we know, it'll be the same, so 0.7 and 0.3. And for this bit, well, green is 0.7, as it has been the other ones, and red is 0.3. You get 2 marks just for putting those numbers in. Work out the probability that the spinner lands on 2 different colours. Well, what I always do with these is this little, I'll show you. Up here is green, green, so green, green. Green, red, so green, red. Red, green, and red, red, for example. There we go. To work out the probability from a probability tree, you multiply across. So I've done 0.7 times 0.7 is 0.49. 0.7 green, red is 0.7 times 0.3 is 0.21, and so on. So which one of these are 2 different colours? Well, the ones I'm interested in are this one and this one, because they're 2 different colours. So that's 0.21. But because you need to add them up, you see my sum there, the answer is 0.42. You get 3 marks for that question, and that's a really nice question to pick up 5 marks on. Question number 20. Okay, this one isn't too bad, but as long as you've studied it at school or at college. Solve 3x squared, take 5x, take 1, equal 0. And it says, give your solutions correct to 3 significant figures. The reason I've highlighted that bit is because that's your flag, that's your cue to use something called the quadratic formula, or the quadratic equation. And that can be found at the front of your exam paper. I think in 2 years' time, the new spec, they're not going to make you remember it, but for the time being, you've got it. And it is there, and I'll zoom in on it. There you go. So a equals minus b plus or minus the square root of b squared take 4ac over 2a. That looks really, really complicated, but it's not too bad. It's just a substitution question. So let's go back to it and see what we can do. Right, here it is. I've written it down there. What you need to know is that this number here, so whatever's before the x squared is always a, whatever's before the x is always b, and whatever's before this, well, and the maths number at the end is always c. So in this case, a is 3, b is minus 5, this is where a lot of people go wrong, and c is minus 1. So we're going to substitute these numbers here into my quadratic formula. So there's my quadratic formula, and I'm substituting in those numbers just at the top of the screen. I hope you can see, and I'll show you what I've done. So b is minus 5, so it's minus 5, and in a minute that's obviously going to make a positive, plus or minus the square root of minus b, so that's minus 5, take away 4 times a, which is 3, times c, which is minus 1, divided by 2a, so that is 2 times 3. And what I do is just do lots of work into these, and I tidy it up as I go, and I hope you can see what I've done. That's the one we just talked about, so the minus minus becomes a 5. Minus 5 squared is minus 5 times minus 5, which is positive 25. Take away, so it makes my take away. 4 times 3 is 12, times minus 1 makes it negative 12. So it's 25, take away, negative 12, over 2 times 3, which is obviously 6. So 5 plus or minus, Take away a minus becomes a positive, so it's square root of 25 add 12 divided by 6. 25 add 12 is 37, so that's how I've got to that one there. Now there's two solutions to this, and you've got to solve this for once when you do 5 add the square root of 37 divided by 6, and one where you do 5 take away the square root of 37 divided by 6. And what I've done, I've shown that here. Here's the one where I add. There you go, it's a bit, just work that one out. And here's one when I take away. So there are my answers there. It does say give it to 3 significant figures, so that's what I've done underneath. The answer is minus 1.85. Sorry, the answer is 1.85 because the 7 rounds up to 4, and this one is minus 0.180 because a 4 will not round up a 0, so you must put that O in. Just go back and have a look at my workings again. The key thing to this, be good at your substitution. But if you've got to solve an equation, so find out the value of x, and it says give it to 3 significant figures, you're going to have to use this quadratic formula. Right, next one. You've got 2 triangles put together. Work out the length of BC. There's 5 marks for this, and we're going to have to do 2 separate calculations. To work out BC, we don't know enough information at the moment. I've put in that's 100 because I can see that's 100, look, because there's 180 degrees on a triangle. Just label that and tell us why. So you can write down there 180 degrees on a straight line. I think I said in a triangle, meant on a straight line. A-R-A-I-G-H-T. Okay. We're going to work out this length here, BD, and we can do this by using something called the sine rule, because I've noticed we know this length and we know this angle, so that means we can, as we know that angle, we can work out that length. And the sine rule is at the front of your exam paper. It's the one that is, there we go, A over sine A equals B over sine B equals C over sine C. So I've written that one. Here we go. Get the hang of this one though. So there we go. I've drawn this little triangle out here, and I've taken this triangle here and put it here. So let's have a look at this. I'm going to try and work out side B. So I've labelled my sides. So I've called that side A and angle A. Those must be the same letter because they're opposite each other. And so that is angle B, and that must be side B because they're opposite each other. So A over sine A equals B over sine B. A is 7.4, so 7.4. A is 80, so it looks sine 80. Angle A, sorry, is 80, so sine 80. The little b, so side B, we don't know, so I've called it B. And angle B is 45, so it's sine 45. That's where the numbers come from. Let's quickly solve this one. So that's what I've ended up with. So I need to find out what B is. So what's happening to B? So rearrange it, get B on its own. What's happening to B? It's being divided by sine 45. What's the opposite of divide by sine 45? Is times by sine 45. So I've got sine 45 times 7.4 over sine 80, and that gives me 5.3133. So that is the length of the side BD. Just a little quick tip here, when you're doing this one on a calculator, if you're not really confident with using brackets, I actually did 7.4 divided by sine 80 equals, then times it by sine 45, because otherwise you might get a calculation error. So 5.133, that is the length of this line here. So what I've done, I've taken this triangle here and I've drawn it down here. Just, so you can see both at the same time. So this triangle is now here, and I'm going to work out the length BC on this triangle. Let's go down and look at my workings for this one. This one, I've used something called the cosine rule, and this is also at the front of your exam paper. There you go, it's that one there. Cosine rule, A squared equals B squared adds C squared, take 2BC cos A. So I'll talk you through that one. Okay, so I've written it out. There we go. Now, again, you've got to label your sides. Excuse me, something a bit fluffy. Okay, so I've called that A because that's what we're trying to find out. And b and c, a bit like Pythagoras, don't really matter too much. So a squared equals b squared, which is 5.3133 squared. Add c squared, which is 5.8, there we go. Take away 2 times b, so that's 5.3133, times c, which is 5.8, times cos 100, because that's cos a. You've got to work through all this. You can see my workings there. You get, I think you end up with a double negative on this bit, so don't forget that and that, and make a plus. You work all that out. A squared is 72.57, so a is 8.5188. The question does say give it to 3 significant figures, so I've rounded it to 8.52. I think the hard part about those questions is actually spotting what rules you need to use at any one time. My personal thing I do with this, and the way I spot it, is that if you've got a side and an angle that are opposite each other, you can always use the sine rule. So when I started doing this question, I just started using that, had a bit of a play around with it, then obviously I could find out that one, then I know that one, then I could look at my other rules for triangles, and worked out the cosine rule would get me that length there. Question 22. Simplify fully this one here. Alright, let's have a look. You've got to factorise the top and the bottom of this equation, so factorising the quadratics. I'll start with the bottom one first because it's easier, because you've not got a coefficient of x squared. So factorise means put it into brackets because it's x squared, double brackets. The trick to factorising this is you need two numbers that multiply to make -6 but add up to make a +5. 6 times -1 is -6, and 6 take away 1 gives you 5. So that's the bottom one done. If you do that, you'll just get 1 mark, which is great. This factorising the top one is very tricky, and there's lots of different techniques for doing it. They're all quite long-winded. It's 2x and x, because that's how you get 2x squared. Then what I do is have a little bit of a play around with the numbers. On these questions, because I've been doing this a while, I noticed that one of the top ones is likely to be one of the bottom ones. So I've had a bit of a play on another bit of paper, and x minus 1 couldn't go there. Then if that's x minus 1, that's got to be 2x take away 3. I can't really explain that briefly, but if you're not very good at factorising quadratics with a coefficient of x squared, have a word with your teacher. When you get to this stage, the x minus 1, they cancel, so you're left with 2x take 3 over x add 6, just those two there, look. That'll cancel, so you're left with those two. Next one. Make m the subject of the formula. So you've got m over v, take away t over b, equals m take t over r. Right, a lot of work this one, but let's work our way through it. I want to do this calculation, m over v take t over b, so I'm going to get the bottom numbers the same. So what does v and b both go into? They both go into vb, so multiply this side by b, that side by v. So that's how I've got to this stage here. I hope that makes sense. That, by the way, there should be a take away. That is not an equal sign, my bad. So now I'm actually going to do this bit, take it away. So mb take away tv all over vb, because it's algebra, I've got to leave it like that. I can't do anything else with it. Now I want to multiply both sides by VBR, and I'm doing this because it will get rid of the bottom numbers. Now, for example, if I multiply this side by VBR, because it's been divided by R, if I multiply by R, that means that R goes. But because there's not a VB at the bottom, I've got to multiply the top by VB. So it would be VB times M, take away VB times T, which is essentially what I've got here. The next one I've had to times by the same thing, because I'm doing the same thing to both sides. Because I'm multiplying by VBR, this VB goes, but I've got to multiply the top by R. So it would be MBR, take away TVR. And if you're not really sure what I've done there, think of it like this. If I put an R outside the bracket, and then I've done MB take VT, MB take VT, if you multiply out those brackets, so it'd be RMB take away RVT. I'll just put them in a different order. You'll get that. Once you've got it like this, you can start a bit of a play with it. I want to get all the m's on the same side, so I'm making m the subject of the formula. So I've added TVR to both sides. what has that done? It's got so it's got rid of that one over here. Taken MVB, and from here over there. So we've got the m's on the same side. Then I've factorised this because m is common in both MVR and MVB, so put m on the outside of the brackets equals that. M is being, when I get m on its own, it's being multiplied by BR times VB. So I've divided by BR take VB, which gives me this here. You can also go a little bit further, and I have moved on, but I'll probably get you the marks up to there to be fair. But if you want to make it really nice, you can, that's what I just had before, you can actually factorise this side as well, like I've done there. But it's a lot of work there for 4 marks, so if you can get that, well done, you're very good at sorting out your algebra. Right, next one. A road is 4,530 metres long, correct to the nearest 10 metres. Kirsty drove along the road in 205 seconds, correct to the nearest 5 seconds. The average speed is 80 kilometres an hour. Could Kirsty's average speed have been greater than 80 kilometres an hour? Okay, well, you're talking about speed, distances and time, so you need your speed, distance, time triangle. Also, because they're talking about to the nearest 10 metres and to the nearest 5 seconds, it's a bounds question as well. So this is bounds combined with speed, distance and time. So we're going to work out her speed. So the speed is distance over time, because you put your finger over speed, look, and it says distance divided by time. So there we go, speed is right. Now, could her speed have been over 80 kilometres an hour? So you want to work out the upper bound for her speed. Now, in order to make the speed as high as possible, when you're dividing, you want the top number to be as big as possible and the bottom number to be as small as possible, because then more of the bottom number goes into the top number, because that's what dividing is. So what is 4,530 to the nearest 10 metres? Well, it could go up to 4,535. It's up to that, it's not including that, but we can still use that in this sum. And we want the bottom one to be as low as possible. So the smallest this can be to the nearest 5 seconds is 202.5 seconds, because from there to the nearest 5 seconds it will round up. If you don't like what I've just done there, here's another tip of doing it. If it said to the nearest 10 metres, if you want to find the lower and upper bound, just half 10, obviously 5. The upper bound is when you add on 5, the lower bound is when you take it off. And for this one, half 5, sorry, I think I might have said half 10 anyway. For this one, it's half 5, which is 2.5. So the upper bound, you add it on, and the lower bound, you take it off. So I want the lower bound. So I've worked out this one here, and it comes to that many, and it's metres a second, because I'm talking about metres here, and my time is in seconds. So that's why it's in metres a second. I need to convert that to kilometres an hour. So because it's in metres a second, how many seconds are in 1 hour? Because I want it in kilometres an hour, and that's 3,600. And how many metres are in a kilometre is 1,000, so divided by 1,000. So it comes to 80.62 kilometres an hour. So yes, she could have been speeding. That's quite a nasty question, but it's 5 marks, but you can still pick up some marks for it if you get your speed distance triangle down, start doing some calculations with it. And also if you look at your distances at the top, if you can round them to some appropriate bounds, maybe label it upper or lower bound, that'll probably be a good idea. To get an A on that paper you're looking at roughly getting around sort of between 65 and 70-ish, but I think on this one it's actually 67. A B I think was 49, a C was 29, and a D was, I think it was 20 or 19, I can't remember. But they're your rough grade boundaries. I hope you did well.